Hello everybody, Mr. Wyatt here, and today we are going to talk about surface area of cylinders. Here's an example of a cylinder right here, this can. You see the bottom is a circle, the top is a circle, and then we have this outside surface that wraps around. This is called the lateral surface. It has kind of this corrugated edging here, but it wraps around the outside of the cylinder. And we're going to be talking about the surface area, which means all of the area of the outside of this figure. We're not concerned about the inside or what it can hold. We'll talk about that in our next lesson. But we're just concerned about the outside. In other words, you could ask yourself, well, how much tin was used to make this can? Okay? Or how much paint would it take if you were to paint the entire surface of this can? Again, assuming or pretending the top is on this cylinder still. And so we have two learning goals today. First learning goal, I can draw a net of a cylinder. Now remember, a net is just when you take a three-dimensional figure and you kind of pull it apart and lay it out in a two-dimensional space. And so I can draw a net of a cylinder and can see that cylinders are comprised of two circular bases and a lateral surface that is a rectangle. We're going to talk about that here in just a little bit. All right, and secondly, I can use a formula to find the surface area of a cylinder. We do have a formula we can use that works every single time. And you won't have to memorize the formula. Anytime I ask you to find surface area, I will provide you with that formula. All right, so let's take a look here. And you can see in this picture, we have a cylinder here. And over here to the side, we have what's called a net. This net is showing what this cylinder would look like if you unwrapped it. If I were to take this can, there is a seam that runs right down the middle here. You can see that right here. There's a seam. If I were to cut right down that seam and open this up and also remove these circles, we have the circle right here. We have a circle right here. That's the top and the bottom of our cylinder. And then we have this lateral surface, and some people are kind of confused. They think, really, that's a rectangle? And yes, it is. By the way, I took this can from the cafeteria about 27 years ago, so it's kind of old. It used to have fruit cocktail in it, so I went and asked down in the cafeteria, hey, can I have one of those cans? They looked at me funny, and they said, well, sure, yeah, you can have that can. What do we don't need it. And I've been using it ever since in class to demonstrate how cylinders are made. Okay, so anyway, here's the label off of that can, and it's kind of old and brittle now, and you can see the fruit cocktail. And if I hold back here far enough so you can see the whole thing, see how it's in the shape of a rectangle? If I curve it around here and connect it at the seam, you can see our circle here, and maybe I'll just put this down here for a second so you can see a little better. And you can see how this is your cylinder, but this lateral surface, when you cut down this seam and open it up, it is a rectangle. So let's take a closer look at this net. You know, I can find the area of a circle by using the formula pi r squared. That's how you find the area of a circle. This one also pi r squared. And since these are in the same cylinder, these are both identical circles. So I could find the area of both of those circles if I just took 2 and multiplied it by pi r squared. Okay? 2 times pi r squared would give me the area of those two circles. And then I can add to that the area of this rectangle here. Well, this rectangle, I can see the width of this rectangle here is actually the height of the cylinder. Okay? The length of the rectangle, this dimension here, is actually the circumference of one of the bases, or both of the bases actually. It's the circumference or distance around that circle. Okay, here's your length. Roll that length around, and it equals the circumference or distance around that circle. And we do know how to find circumference. Circumference is pi times diameter. So what I could do here is just put pi times diameter here and use that to represent the length of this rectangle. So how do I find the area of that rectangle? Well, I take pi d here, the length, and multiply it by h, the width. So pi d times h. That's the second part of my formula for surface area of a cylinder. So to find surface area, we would take 2 times pi r squared plus pi d, the circumference, times h. So this gives me the area of the two circles. This gives me the lateral surface, its area, that rectangle. All right? So I just wanted you to see where this formula comes from. And here we have the formula written down over here as well. S equals 2 pi r squared plus pi dh. And the reason I have parentheses around each of these sections is because we need to find each of these areas separately. And once we have those areas, we can add them together to get the total surface area of the cylinder. Take a look at this cylinder here that says find the surface area of this cylinder. It doesn't say anything about rounding to the nearest tenth or anything like that. So once I have it, I'm just going to call it good. Notice the formula requires us to find the radius and the diameter. So I'm going to start by just writing r equals and d equals. Let's get those measurements. Here I see 9 meters. Is this the radius or is it the diameter? Well, if you look at the picture, this segment goes all the way across this circle. So that must be the diameter. So the diameter is 9 meters. The radius would go halfway across from the center to the outer edge of the circle. And so the radius would be half of that 9 meters. 9 divided by 2 is 4.5. So now I know r is 4.5, the radius, d is 9, the diameter. H, the height of this cylinder. What is the height of this cylinder? If you're thinking 9 meters, well, no, that's not the height. The height is actually 12 meters. And you might be thinking, well, Mr. Wyatt, height is supposed to go up, down. Well, it usually is up and down, but you see this cylinder is laying on its side. Okay? Height is technically the distance between the bases. The bases are circles. If you look at this can here, which is in the shape of a cylinder, here is the height, top, bottom. But if I turn the can sideways like this, did the height change? No, the height is still going that same direction, but now it's traveling left-right. It's the distance between those two circular bases. So yeah, just be aware of that when finding the height. Height doesn't always mean up, down. All right, so let's write our formula down. And I know it's already written down, but I want you to write it again. S equals 2 pi r squared, put that in parentheses, plus pi dh, we want that in parentheses. And then I'll start filling in some numbers here. So here I have 2. Oops, let's get that box out of there. 2 times pi, 3.14, times the radius, r we found was 4.5, squared. All right, that's the first part. Plus, and then in our second set of parentheses, pi, that's 3.14, times d, the diameter, which we know is 9, times h, and the height we determined is 12. And parentheses. Now, if you have a scientific calculator, there are parenthesis buttons on there, so you could actually enter this whole thing exactly as it shows. First parenthesis, 2 times 3.14 times 4.5 x squared, and parenthesis, plus first parenthesis, 3.14 times 9 times 12, and parenthesis. And then just hit enter. It'll do all the work for you. If you don't have a scientific calculator, for example, look at this one here. This is my regular calculator that I'm going to use. I'm going to solve each part separately, write those answers down, and then I'll add them together. So on the left side here, I actually need to do the exponent first. So I'm going to take 4.5 squared, which means 4.5 times 4.5, and then times 3.14, and then times 2. It equals 127.17. Plus, and now I do the math on the right side, which is a little bit easier since there is no exponent. 3.14 times 9 times 12. And that equals 339.12. I'm writing all my work down here. It's going to be very important that you show your work. Some of you might be thinking, well, I can do it mentally. Well, you probably can, but I want you to write it down because otherwise you can make careless mistakes. All right, so your teacher might require you to show your work, maybe attach it to your assignment when you hand it in through Google. So anyway, let's add these together. 339.12 is still in my calculator, so I'm just going to add 127.17. And it equals 466.29. My directions don't ask me to round or anything, so I'll just leave it as is. It's surface area. Area is always square units. We're working with meters here, so my label is square meters. Okay, 466.29 square meters. Let's do one more example here. Find the surface area of this cylinder. First step always is the same. Write your formula down. S equals 2 pi r squared. I have this in parentheses. Plus pi dh. I have that in parentheses. Now I'm going to rewrite the formula, except now I'm going to fill some numbers in. First, though, let's figure out, since I need to know the radius and I need to know the diameter, let's find those values and write them down. This 4 centimeters here, is that your radius or is it the diameter? Well, I see it is connecting the center of the circle to the outside of the circle. So that's the radius, 4. The diameter goes all the way across, so I need to double this to get the diameter. Diameter is 8. So now I'll start substituting in some numbers. So I have 2 times pi, 3.14, times r squared, 4 squared, end parenthesis, plus, and then second set of parentheses, pi is 3.14, times diameter, 8, times height. The height does go up, down in this one. It's 18. Remember, height is the distance between those bases. Okay? So I'm going to, again, solve each side separately. So over here, 4 squared, I actually know what that is. That's 16. Did you know that? 4 squared means 4 times 4. So I have 16 times 3.14 times 2. What would that be, about 100.48 maybe? I better check it. 16 times 3.14 times 2. Yep, 100.48. Plus, and then over on the right side here, I have 3.14 times 8 times 18. And that equals 452.16. All I have left to do now is to add these together. So I'm going to do that. And I get 552.64. Area is always square units. I'm working with centimeters in this problem, so I put centimeters squared, or square centimeters. That's my surface area, 552.64 square centimeters. All right, you can watch this video again as many times as you need to. Otherwise, I hope you do well on your assignment today, and I will see you for the next lesson.